All right. Good morning, everyone. I'm Michaela Pochner. I'm managing editor at No-Till Farmer and filling in for McCain Vogel today. Thank you for joining us for today's digital demo, Improving Growers' Bottom Line in Phosphorus Uptake with RhizoSorb Fertilizer. Brian Reinecke from Phosphollutions is going to tell us about RhizoSorb, a fertilizer technology that decreases phosphorus use by up to 50% while preserving yield. But before Brian gets started with the presentation, I just want to let you know that we'll be taking questions throughout the presentation. You can submit those using the Q&A icon at any time, and then we will take those all at the end of the presentation. And then we are also recording today's digital demo in the event you want to go back and watch it or share it with anyone on your farm team or neighbors or anything like that. So without further ado, I will hand it over to Brian.
Thank you very much, Michaela, and good morning, good afternoon, everyone, to wherever you are at. We thank you for taking the time to join us today to learn about Phosphollutions and this RhizoSorb technology. A little bit about my background. I am 35 years plus in the agriculture production business, have lots and lots of experience from family farming operations to my own farming operations. And overall, my passion has been for agriculture just about my entire life. I love agriculture. My goal is to continue to learn as much as possible that I can to help us all improve what we're doing and take a critical look at the future for our yields and our soil management systems and the way that we approach soil fertility. So my goal is to bring that knowledge to all of you here in the field. And I really enjoy helping growers solve problems and help us improve our efficiency and profitability. Today, I'm going to be sharing some exciting new news and new information about phosphate efficiency. Some of you may have heard a little bit about us prior to this call here today, and because we are a company that was founded in 2016 under the belief that there have to be better solutions for more sustainable ag production practices. And as we're going to learn today, there are many challenges that we face in the whole idea of soil fertility, plant nutrition, crop output, return on investment, and many subjects that are all near and dear to our hearts as ag producers. We are focused on developing new technologies to improve phosphorus efficiency and moving on to other sciences as well. And that's going to also have a positive impact on reduction of environmental use efficiencies and runoff and those types of things. This technology has been studied and developed and proven out now for over 20 years, backed by academic and farm trials, and we'll get into some of this as we go along. A little bit of our history going back to 2016. This began as an idea and a concept from our CEO, Hunter Swisher, who learned about RhizoSorb from a professor, Dr. Jonathan Lynch, at Penn State University. And through a series of processes, we have come to 2023 through an evolution of trials and plots and information, both small scale and large scale, to bring us to where we are at today in 2023. And if you've seen RhizoSorb, if you attended the Commodity Classic here back this past February or March in Florida, this is where we formally launched RhizoSorb into the agriculture system. So if we start digging into phosphorus fertilizer and really what it needs, our focus is really driven by the necessity to discover these more efficient uses that's going to better optimize efficiency. As we know or should know, many of our commercial fertilizers that we're using today are extremely inefficient relative to what we actually get into the crop versus the cost or the investment of these commercial materials. And as science has improved and knowledge and understanding of soils and overall testing methods has gotten better, we've actually come to learn that phosphorus is really only 10 to 30% efficient. So there's got to be some better ways as we evolve into the future with ag production and science and technology. Phosphorus is a key area that we are focused on in order to help optimize efficiency, provide sustainable solutions, and preserve yields and eventually reduce costs and greenhouse gas emissions and various other things that are important to us as producers, as well as to the environment and land stewardship. Getting into a little bit of the phosphorus soil dynamics, phosphorus fertilizer, commercial MAP and DAP are very highly soluble materials in excess water and moisture. And this is really a good thing until soil chemistry takes over. These materials are highly reactionary to other soil constituents like calcium, magnesium in higher pH ranges, and aluminum and iron in lower pH ranges. And phosphorus is either going to be mineralized or solubilized and immobilized in soil solutions. Our crops are going to only absorb what is made plant available by chemical and biological actions when there is only adequate moisture to do so throughout the growing season. Less than 2% of soil available phosphorus is actually available to the crop due to just the general dynamics of soil conditions, the basic soil conditions like soil chemistry and pH. One of the phosphorus, once phosphorus is fixed to the soil, it is not easily made plant available. So some of the other things that we have to be at least cognizant of and beginning to think about is that environmental losses through phosphorus and leaching and erosion. Phosphorus is actually and can actually leave the soil attached to soil particles and soil colloids. So here's that 10 to 30% of applied phosphorus that is used by the plant comment, again, that I mentioned at the outset. Science has shown that through this process, it really then only becomes a math problem as to how efficiently we are utilizing our dollars and investments in fertilizer to what we're actually getting out of the crop. So we need to become really good stewards of these soil testing methods and each individual crops and land that is all represented here on this call today. So phosphorus is highly dependent on several factors. First of all, regarding phosphorus availability, it is totally dependent on the soil's ability to replenish that soil solution with orthophosphate so that the crop can remove it. Secondly, through phosphorus uptake, as an immobile nutrient, it becomes very easily tied up, as we have discussed, and unavailable for the crop to use. And because it is not mobile in the soil, root interception is absolutely necessary for plant uptake. Having enough available phosphorus in the soil solution becomes a limiting factor for early as well as late season crop development with regard to phosphorus nutrition and its contribution to the entire plant cycle, as well as the yield, most specifically, is what we're all interested in. Root interactions. I mentioned root interception accounts for approximately 3% of the overall phosphorus uptake, which is not very much. So the other ways that we are able to get phosphorus into the plant is primarily by diffusion, which is the movement of water nutrients across from high concentration to low concentration, and that is the majority of the way that phosphorus is taken up by the plant. So through this chemical gradient of high concentration to lower concentration is how phosphorus is going to move. When the plant takes a unit of P, the soil needs to replace a unit of P in that solution for phosphorus to be used. Two things that we need to remember is, number one, no matter what we do to the soils, our soils always have to be and will return to its natural equilibrium. And another important thing is that plant roots only explore, according to some of the science and research, about 1 to 3% of the total soil's volume. So if we have to have root interception or diffusion, it's imperative for maximum plant optimization of phosphorus uptake in order for there to be enough available phosphorus in that soil solution to be diffused and moved into the plant in that small amount of space, 1 to 3% of total soil volume. So, taking a quick look at soil testing values and the traditional ways that we're all familiar with how soil testing is done. Current phosphorus recommendations are really only based on a correlation to yield. So, when we have our soil test extractions done by whatever means that you do, Bray, Olson, or Malik, we are going to receive back a value of concentration of phosphorus in that soil test, which then we take that and try to correlate that to yield. And what we see here in this diagram is the amount of extractable phosphorus in the soil clearly increases yield up to a certain point until you get to a plateau where additional phosphorus is not going to be contributory to yield. This is called the critical level, and it's traditionally what our soil targets are for our phosphorus levels. There is, however, quite a bit of variability in this data, and the reality of the situation is a lot of this depends on all of your soil types and the conditions with which you're growing things in these conditions, weather and so forth. So if we don't really know how phosphorus levels are going to result in proper nutrition and yield, because the soil test recommendations are based on the averages. So as soil testing gets better, we're being able to more fine tune what the values in our soils are and how they will relate to yield based upon a system of understanding, if we have a soil test value, how much of the phosphorus is the soil actually going to move into solution. And those numbers are quite different. What it does not consider here in this slide is the phosphorus concentration, the buffering capacity, rate of diffusion, and the predicted phosphorus uptake for the crop. So the plant demand curves are what they are with our crops, and the soil, what is the soil's ability in order to be able to supply enough nutrients at the time the crop needs it. From my experiences across North America and looking at soil test analysis and relating these values on a page to the physical characteristics of visual inspection of the field, I've come to the realization, it's very certain to me, that there's more fertilizers in our soils today than we know is there based upon how we test it. So improving our testing methods and having a more clear understanding of the correlation of our soil test to crop plant demands and that soil solution in order to bridge that gap between what the soil can physically provide in a growing season to what the crop is needing. Phosphorus uptake. Many of you have probably seen a graph like this somewhere along the line, either in webinars or events that you've attended. This is a accumulation of many years of study from University of Illinois, it looks like. This might even be Dr. Belo's work. But as we take a look at phosphorus uptake in corn, for example, this has been studied again for many, many years. And while early season phosphorus is important, and in our corn and soybean type of rotations, especially corn, we're very actively looking at early season growth and crop development. There is a significant upward trend in phosphorus demand as the crop that happens in any crop, whether it's corn or tomatoes or any crop that we are growing, plant demand for nutrients like phosphorus skyrockets when that plant and crop moves itself from vegetative to reproductive growth. So it's important to start out strong early with good available soil solution phosphorus levels, but then as we get later in the season, we need to begin to evaluate how we are going to get enough phosphorus in the plant in order to support yield. As you see here in the corn example, phosphorus is over 75% of the contribution to grain and yield. So if we don't have it there later in the season, how can we get it? And then the question would be, how do we get from early season good crop establishment to yield? And that's one of the things we're going to visit here today with about RhizoSorb. So looking at this, going more from a top view down into the roots, a well-known scientist that I mentioned here early on, Dr. Jonathan Lynch at Penn State University, has spend a lot of time in studying the overall concentration of root architecture, in this case relative to phosphorus concentrations. And through his research, he has shown that excess phosphate does not necessarily contribute to greater yields, and it does have some positive and negative impacts on overall root structure, as indicated here in the slide. 0P growing media, represented on the left side of the slide, produces a root architecture that's very similar to plants grown in high levels and high concentrations of phosphorus. So it's vital to growing high yield and high quality crops that we get the phosphorus application and the rate correct, so that we stop over applying phosphorus as a main strategy to overcome that nutrients inefficiently from a commercial fertilizer applications systems that we use today in MAP and DAP and so forth. So getting into more of the little bit of nitty-gritty, some of the negative impacts that we can see and usually see from excess uses of phosphate is negative impacts on root, a reduction in overall yield performance, going back to that gradient slide that I showed you. Adding more phosphorus is not going to necessarily get you to the yield point that you're looking at. In truth, a very small amount of the phosphorus that's actually applied is available for crop use in the current season. Through all of this research, again, we're talking about an overall 10 to 30% efficiency factor, meaning that 70 to 90% of what we're actually applying gets tied up in the system and unavailable to the crop. Current soil testing framework analysis and application is getting better, but still some of the ways that we are looking at things today lead us to the idea of over applying phosphorus. And some of the misconceptions that we tend to think of, I mean, I used to think of them too, is that if we applied phosphorus, apply all of our fertilizer needs in the fall, that it's just going to store itself in what we call the soil bank for use next season. And that's not really the case. The soil testing framework leads us to that concept of over applying. And then we get into a situation of how do we manage soil test levels to phosphorus levels, and with some of the mandates and some of the things that are coming from an environmental perspective, these are things that we need to be aware of and begin to take a proactive approach in order to start to better manage those systems within our own operations. The solution that we have come up with, again, from over 20 years of research and study now, is RhizoSorb. And this material is designed in such a way to give the plants the phosphorus when they need it and store it in that soil solution when they don't. So we're going to get into some of the specifics now of RhizoSorb. Taking a look at some of the technology behind it, RhizoSorb is the next generation of proven science that is now coming to market for increasing nutrient use efficiency for fertilizers. It is embedded directly into conventional fertilizer production systems at the time of production, so it comes to you ready to use in the field. Your retailer, or if any of you on here are retailers, this is not something, an added step in your operation that you need to do at your plant in order to provide fertilizer to your growers. RhizoSorb mimics natural soil chemistry to store and release these nutrients over a chemical gradient, and does so based on the chemical gradient rather than environmental conditions, allowing for release throughout the entire growing season for a longer period of time relative to MAP and DAP. We've proven through this extensive research and many years of on-farm trials and multiple sites, small plots, large plots, labs, and so on, that RhizoSorb significantly increases the efficiency of phosphorus as applied fertilizers. So here's that slide again from a RhizoSorb perspective, the future of phosphorus, addressing several areas that are important to all of us as growers. First of all, RhizoSorb comes to you as the only patented fertilizer additive embedded on the phosphorus granule, ready to use. during production and is proven to maintain or increase your yields with overall 50% less applied phosphorus nutrients, not total product, and we'll talk about that here in a little bit. Providing these sustainable solutions through some extensive runoff studies that we have conducted and implemented with some researchers in New Zealand. These studies have returned results that show RhizoSorb is able to reduce runoff by approximately 58 to 60%, and also does show a reduction in greenhouse gas emissions. I mentioned yields. We as growers are always interested in learning how to improve our yields through the excellent genetics that we're already applying or purchasing and planting in our fields. Yield is always important to us. So RhizoSorb has been demonstrating equal to or greater yields while using less amounts of product. And then the other important thing for us as growers is how do we manage the cost, because farming is not getting cheaper to do, and all of our inputs seem to be going up. And RhizoSorb, we bring that to you as an opportunity for you to help you better manage your fertilizer inputs by providing you approximately a 10 to 15% cost savings on a per acre basis. From an analysis point of view, you've probably figured out and guessed by now that RhizoSorb is a dry granulated fertilizer derived from monoammonium phosphate and carries an analysis of 839.0. We get this question quite a bit as our team is out in the marketplace looking at and talking with growers and retailers. We get this question: how does RhizoSorb compare in granular quality specifically to 1152O? So as you can see here, very, very consistent across the range of measured expectations or measurements that are done with monoammonium phosphate 1152O. So you can be confident that this will integrate very, very well into your existing system by utilizing RhizoSorb and replacing 1152. I would like to also call your attention to this area on the slide here. RhizoSorb carries with it a measured approximately 38 to 40% lower salt index. So us as growers, if we realize that every amount of fertilizer we apply in any form has a relatively high salt index, RhizoSorb is that opportunity for you to apply lower amounts of salt, increasing your crop's use efficiency of phosphorus, and also taking into account from a biological perspective, the lower amounts of salts, your soil biology and things that you're doing to work in that side of the equation provide better offerings for you for improvements in your soil systems. I'm going to talk a little bit about anionic exchange capacity. Not much information or discussions do we generally do in the industry about AEC, as I'll call it for short, because the rest of the complete word is difficult to say. But most of the time we spend talking about CEC, cation exchange capacity. Not much attention to AEC yet. But we have to realize and understand that AEC is the opposite, yet equally important to the overall discussion of nutrient exchange and nutrient availability in terms of determining the quality of our soils. Soil pH is also a key factor in determining anionic adsorption rates. According to the University of Hawaii, AEC is dependent upon soil pH, or the pH of the soil, and increases, meaning your negatively charged nutrients increases as the pH of the soil decreases. This is an area within Phospholutions, as well as the academic arena, of continued scientific research to further understand the similarities and differences between AEC and CEC. And as you can see here, some of the examples of negatively charged nutrients, if you didn't know, phosphorus is negatively charged, and it is also in that same class of negatively charged nutrients like chloride, sulfur, molybdenum, boron, and nitrogen, nitrate nitrogen to be specific. So talking about adsorption versus desorption. So when we're manufacturing RhizoSorb, the adsorption of phosphate from the onto the surface of the RhizoSorb during that manufacturing process, meaning that it is covering the 1152O, and then when it enters into the soil solution, the desorption and the desorption rate from RhizoSorb into that soil solution is driven by that chemical gradient that we talked about here previously, in which the soil solution gives up a phosphorus ion, phosphorus nutrient and mineral when the plant needs it, and that relationship and exchange continues to go on throughout the course of the time with RhizoSorb in the soil. A great way to describe RhizoSorb is that it acts as a buffer for releasing phosphorus into the new soil solution that's protected from what I like to call cationic adhesion by calcium, iron, and aluminum, so that it remains available to the crop and not tied up with pieces and parts of our soil system. Through some of our studies, many of our studies, we've seen improved plant uptake and utilization of phosphorus when using RhizoSorb. We've done this by applying 50% less P2O5 to the crop versus any grower standard practice. So any of you growers that might be on here, think about how you are using MAP today at the whatever rate that you are using, and then our recommendation rate is roughly half of that on a actual amount of phosphorus content, P2O5. So when we have done this, taking a look at the circle here, let's just say that MAP at 100% of your grower standard rate is 80 pounds of actual P2O5. The RhizoSorb representation here in the bar graph is equivalent to 40 pounds of P2O5. And what we're seeing here is about a 3% increase in plant phosphate utilization and use efficiency and movement into the crop through a lower use rate. This is particularly important as it clearly supports our research results and our confidence that when you're using RhizoSorb, even at lower rates, we're confident that it's getting into the crop and into the plant and thus moving through its plant life cycle system to give you the end result of yield at harvest time, which we're obviously in right now. So from a historical perspective on our commercialization track and things that we have done with testing and trials from 2019 to 2022, you can see an extensive amount of trials across a wave of mediums that we have taken a look at, from labs to grow rooms, small plots, contract research, university, large-scale grower plots. Currently today in 2023, we have a significant amount, I believe it's over 50 or 60 additional field level trials that we're doing out in the fields to further ground truth and develop information to support our recommendations and science and technology of RhizoSorb. So by the end of 2023, when all of our data is collected and compiled over the last 5 years, we will have an extensive database of information to share with you in the marketplace of over 550 trials. So we've done all the work, or a lot of the work, early in order to be able to bring to you supportive information that will help you make some informed decisions as to how you will move forward in 2024 in your cropping systems for next year and the years beyond. A recap of 2022, 93 trials over 12 states, primarily in corn and soybeans. And here in 2024 coming up, we're going to be looking into some additional crops as well to expand our crop use with RhizoSorb. Taking a look at, again, at 22 application types, we've done varying different types of applications: banded, broadcast, in furrow treatments, different climate patterns, soil conditions, soil pHs, and everywhere you go, you're going to have a slightly different makeup of the soil chemistry, as I like to call it, or the soil profile. So we have a good range and background of many different sites and scenarios that have to be or would be applicable to any of you here on this call as you begin to look for more information. Multi-year trials, which are continuing to be ongoing, and varying different soil types. Proven to preserve yield using 50% less phosphorus. This is a snapshot of what our footprint. If you take a look at the map, I'll get laser point here. Take a look at the map. Our footprint is very wide range of footprint with a heavy concentration, obviously, in the corn belt here. A lot of our work has been done on corn and soybeans. I would like to have you take a look at the entire footprint and then look at the the right side of the screen as we take a look at yield in a application of RhizoSorb versus a grower standard practice in 2021 and 22 on soybeans and corn. Noted here is a 5 bushel increase in advantage on soybeans in 21, and in 22 there was an average of a 1 bushel. Taking a look at the corn, +5 average across everything, and a +3 in 2022. So I'm going to highlight Iowa for a second, and the concentration of trials that we had there, we seem to have in 2022 a very good yield response of a +3.6 bushels an acre, primarily because the weather conditions in the areas of Iowa that we were specifically had these trials had weather conditions, rain events, and so on that was able to keep more of our soil solution nutrients in available crop use form so that it could be moved. Up here in the northern parts of North Dakota, it was drier, so our yield results obviously were not quite as good. Doesn't matter what you are using, if you don't have adequate soil moisture in order to mineralize and create and put these nutrients in soil solution, it's not going to move to the crop very well. So a very, very good long, wide footprint that we have some success in that I think is really valuable information for you to take a look at. Multi-year phosphate study trials. I'll pay attention to the right side first. I mentioned so far through this presentation that we are able to utilize RhizoSorb and be able to maintain or increase levels of plant phosphorus use efficiency in the plant tissues as read by plant tissue analysis. Excuse me, 2019, 20, 21, and 22 in a soybean corn, we see very consistent results in tissue test P showing up and being active and available within the corn and soybean plants, because this is across the entire scope of our trials, to show very consistent, statistically accurate, even results with RhizoSorb versus the grower standard 100% phosphate in a year-over-year setting. How that relates to yield over on the left side of the screen in the same years, take a look at the trend up in yield when using RhizoSorb at roughly half the rate of P2O5 that you would normally use. These trials were contracted and conducted by Penn State, and I think some of these might have been out on the East Coast, and East Coast yield that year. I've spent a lot of time on the East Coast in the past couple of years, and 2020 was fairly dry, so that would be one of the reasons why we had even a yield bump, but a much lower than expected yield for those of us here in the Midwest. Taking a look specifically at soil test phosphorus levels relative to grower standard practices yield calculation on the y-axis. On the x-axis, we were looking at soil test P levels on a Bray test less than 20 parts per million, in the range of 20 to 40, and then greater than 40 parts per million. Looking at the overall results in on-farm trials for how RhizoSorb performs in various soil testing levels, approximately a 4.7 to almost a 5% increase in yield relative to grower standard practice in the area of places where phosphate was used at, phosphate soil test levels were at less than 20. In the range of 20 to 40 and greater than 40, statistically even with your grower standard practice. However, remember, this does not mean that RhizoSorb is not working. RhizoSorb is still working, is still providing the equal to scenario that we have talked about within your yield expectations. We were using 50% less actual P2O5 in these trials to create this representation of equal to your grower standard practice. And it happens to be in 2022 corn, the results for the same conversation mirrored very, very closely to what the overall yield results were, given the soil test levels that RhizoSorb was used in. We've talked a bit about application methods and some of our on-farm trials and a broadcasted application, 103% of grower standard practice on yield. And in a banded situation, this was 100%. Now, in my area of South Dakota, there are growers that are starting to do more and more banded, deep zone banding of phosphate primarily because they are knowing and realizing and understanding that broadcast phosphorus is not MAP is not providing the benefits to yield that they are looking for. So they're banding, and in many cases, when we go to banding situations, what a lot of growers will do is take their broadcast rate and then reduce it down already because you have a higher concentrated form. And this is what we were doing as well with RhizoSorb. An overview of on-farm trials with 50% less phosphorus, 62 trials with over an 85% success rate, equating to an average of 2.3 bushels per acre advantage on corn, with a 50% reduction in actual P2O5 used. This is pretty significant, and it continues to add to our confidence level of what RhizoSorb technology, the science and technology that we have created with RhizoSorb material 8390, is that 85% of the time we can expect a positive result. Looking at Iowa specifically, going back to the footprint slide, 31 trials in 2022, resulting in nearly a 94% success rate, giving you the 4.9 bushel average per acre yield advantage. Again, with 50% less phosphorus. So for those of you that might be on this call from Illinois, this is a farm trial site out in Illinois, taken nearly just over a year ago. And you drive by the field, and we would all like to see this representation here. This was RhizoSorb treatment versus the grower standard treatment. And when it actually came to yield, it was about equal to a slight increase. But here's the important factor, is that with the reduction in phosphorus from RhizoSorb, we were maintaining, or in this particular case, had an increase in the actual average percent of phosphorus utilization that had been moved into the plant. So this is some good supporting information that we're driving more phosphorus into the plant, and in many, many cases, corn respectively, 85% of the time we are seeing positive yield results. In soybeans here for a second, 21 trials, averaging 1.5 to 1.67 bushels an acre, 76% success rate. So we continue to learn more about what RhizoSorb can do within our soil systems. And at the end of the day, us as growers are most important with the output and yield. So from a confidence level, if somebody came to me and said, you've got a 75 to 85% chance of success rate here, I'd be like, let's put some out and let's try it. A few on-farm demos here from this year out in Nebraska in a strip-till situation. What I'd like to call your attention to, and these were corn samples that were taken this summer here back in July, I believe it was, July or early August. 34 pounds of actual P2O5 from RhizoSorb against a grower standard practice. And you can see very consistent stalk size and overall plant height. But the RhizoSorb root system appears to be more fibrous and more extensive and spread out than the grower standard practice. In Bartlett, Nebraska, 52 pounds, grower standard P2O5 from MAP, 26 pounds of RhizoSorb. Again, a very consistent pattern of growth with a more extensive root system. In theory, roots help to make your yield, but you got to have all the other factors in place in order to realize those benefits as well. Taking a look at Nebraska, north central Iowa to eastern Iowa, and then over northeastern Iowa, LaPorte City. Again, we're looking at ears now that were pulled as samples here in August. 100 pounds of P205 in Polk, Nebraska, strip till, 50 pounds. I do not know specifically what this rate was, but you can see better RhizoSorb benefits from the corn ear with RhizoSorb treatment, and then 70 pounds versus 35 pounds. These plots are probably in process of being harvested now, so this is going to be some really good information that we get to add to our data set here coming into this fall and winter to be able to turn back out to any of you on this call that would like it. So we can't talk about everything that we've talked about with RhizoSorb without providing you some application guidelines. So there's a lot of information on this slide. I'm going to call your attention basically to the middle of the slide, whereby this gives us an indication of the phosphorus test recommendation. If it was calling for 80 pounds of phosphorus, your application rate of MAP 1152.0 would be 154 pounds of product per acre to get this 80 pounds. Our RhizoSorb recommendation is going to be right here in this 100 pound per acre application rate. So if you're doing the quick math, this is roughly 1/3 less total product to be equal to or better in performance on a soil test recommendation calling for 80 pounds of phosphorus. So as we begin to wrap this up, I'll just list and highlight some of the grower benefits that we've talked about through this presentation. Increased phosphorus efficiency by at least 50%, improving our return on investment nearly 20% or slightly more. Decreased phosphorus runoff, as I indicated from the New Zealand studies that we have completed and done, which we're going to be implementing some of those here in the US and North America as well. 58% runoff measurements reduction, and then reduction of overall phosphorus rate by 33%. Now, keep in mind, this is a reduced application rate of total material, which will give you increased phosphorus efficiency and overall less actual phosphorus used. So this is some information concerning our contribution and our support of the sustainability messages that are beginning to become more and more prevalent in conversations. Here's this New Zealand Plant and Food Research Institute study that I referenced, showing 58% reduction in runoff potential and 84% reduction in leaching, increased biomass, decrease of carbon emissions, and some of those things that are becoming more and more of a conversation point and discussion and debate points around the world that we're experiencing today. So where can we get it? Product availability, RhizoSorb is available through your retailers. Our team listed here, Brian, Ben, Julie, and Dave, are currently out in the marketplace right now talking with growers and talking with retailers to provide information to support what our research has shown in order to bring you some good advanced science that has now been proven over the last 5 years, more specifically, and this outstanding team can give you some excellent information on a more localized basis if that's important to you. So please take their information down here and don't hesitate to give them a call. Additionally, you can take my information down here. As a director of agronomy here with Phosphollutions, I'd be happy to do everything I could to receive an email from you with any questions and try and get that back to you as quickly as I can so that you have the information necessary that you're looking for in order to make those decisions. And I believe that about wraps it up for me. So I'll turn it back to Michaela. And I believe we have some time for some questions. So thank you, Michaela.
Yes, thank you, Brian. And we do have some questions that already came in. And just a reminder for everyone that you can submit those using the Q&A box. So feel free to do that as we start going through the list. It looks like we have some general questions and then some about the trials specifically. So we'll start with the general ones. Ed asks, where does the cost of RhizoSorb per acre fall compared to the 10 to 15% P fertilizer cost reduction cited?
Okay, so that's a great question, and I'll give you kind of a top view, and I'd encourage you wherever you are at, reach out to our regional sales managers and key account managers for more specific information. Generally, our RhizoSorb pricing follows MAP, and it is currently positioned at about a 30 to 35% premium over MAP. However, you are able to, as we talked about in this presentation here today, you are able to use lower rates, which is where your cost savings come from on a per acre basis. So it will be a little bit higher per ton, but your actual calculated rate and cost per acre is going to be less by using RhizoSorb. So I'd encourage you to contact our regional team for more specific information.
Okay. And then next up, a question about the production process. So it's during the RhizoSorb production process, do you use phosphate solution from which the P is absorbed onto the MAP?
So throughout the reaction process, the mining and reaction process and production of MAP or DAP, that is the area in which we incorporate the RhizoSorb technology. And from a production point of view and a very high level manufacturing point of view, some constituents involved in the production of MAP or DAP are removed and replaced with the RhizoSorb technology. For example, there's a reduction of ammonia used in the production of RhizoSorb than traditional MAP. So you can only have 100% of 100%. So in order to create RhizoSorb as the 839.0, we had to remove some of the constituents in the manufacturing process in order to incorporate the RhizoSorb and embed that actually on the 1152.0 krill.
Okay. And then this question is in reference to one of your slides about the different steps to get this to commercial availability. So this one asks, were the grow room, greenhouse, or small plot tests also carried out by Penn State or by others?
So some were at Penn State, and we have resources with independent contract researchers all over the country that we are engaged with to do a lot of these plot studies, small plot studies that you've seen here in today's presentation, as well as continuing to advance our portfolio and our research in other areas with independent contractors as well as universities. So the answer is yes to everything, I believe, from a general sense.
Okay. And then talking about Iowa as the spotlight tests, were there any positive impacts in Iowa in regard to the reduction of nitrate losses from the demo fields?
That is not something that we have specifically looked at, reduction of nitrogen from the use of RhizoSorb. Those are two different ideas and concepts to the conversation. We are specifically at this point in time looking at phosphorus, phosphorus use efficiency in soils and that chemical gradient that we talked about for release. At the same time, we are also looking at how phosphorus reacts and is utilized in the soil by natural mineralization. And that's a good point to bring up at this stage, I think, is when using RhizoSorb, you're using RhizoSorb in a very similar manner than you are with MAP. You are still going to have your natural soil chemistry taking place for natural soil mineralization and biological action within that soil profile that's going to continue to contribute what it is currently doing from a natural state of use or mechanism in order to provide the nutrition to the crop. So there's really two mechanisms here. RhizoSorb used, again, very similar to MAP in the way of what we're trying to do is increase phosphorus use efficiency by getting at least 50% more efficient use of P, while at the same time the soil is going through its natural processes.
Okay. And then this question is in regard to the North Dakota testing. It asks if there are nearby lakes impacted by HABs, is there an opportunity to model the impacts of 50% less P use to aid in the control or mitigation of HABs in this lake?
That is something that we are currently working on implementing is those types of studies to study runoff impacts here in North America to, I'll say, validate and quantify what we already know about the New Zealand study. The New Zealand, I think a lot of this has to do with some of the current existing regulations in other countries. May very well be that New Zealand has some tighter regulatory authorities and mechanisms and requirements for phosphate, which is most likely the reason why we implemented that study there first. But this is also going to be a piece of what we're doing here in North America as well. That's actually something that I'm currently working on for 2024. So good question.
Yeah, that's exciting. So Sue asks, did the year-on-year test show any improvement in soil health regarding P? Were you able to apply at the same rates year on year?
So that is something else that we are currently in the process of looking at, soil test P levels and what happens with year-on-year use of RhizoSorb. My belief is at this point in time is because there is, as I mentioned, made a statement earlier, more fertilizer in our soils than we know is there based on how we test it. Our feelings at this point, our beliefs at this point is that we're going to continue to maintain those soil test P levels, again, because RhizoSorb is that mechanism for providing more efficient crop use phosphorus in available solution in the given crop year. So the resources in the soil are still going to be providing what they provide. What was the rest of the question?
Let me just scroll down here. Were you applying at the same rates year on year?
So yes, we have a number of growers. I believe it's about 50 to 70 growers that some of them are in their second year, some of them are in their third year of use. And so far to this point, we've not seen any deleterious impacts or effects on soil test P. But that is also to some extent a moving target because you're going to get different soil test readings depending on the time of year and whether or not, even if you take a soil core sample from the exact same spot you did last year, dependent on conditions, you could get a different reading. So it's somewhat of a moving target. However, this is a subject that we at Phospholutions are definitely pursuing right now. We've been working on it. We're going to continue to work on it so that we have a more solid answer.
Okay. I have one more question in my queue here. So this is my last call to everyone in the audience to submit any questions that they are thinking about and want answered before our end of the time here. So this question says, any plans to apply RhizoSorb technologies to DAP?
Well, we currently have the abilities to do that, and we tend to talk about MAP because that's probably the most popular phosphate in certain areas of the country. We do have some customers that have expressed to us that they are using more MAP than DAP. So long way to answer a short question is yes, we have the ability to build RhizoSorb into DAP or triple super. It's just a matter of having the tons to justify the manufacturing.
Okay.
Good question.
Yes. Thank you to everyone who submitted questions and for everyone who attended with us here live today. As a reminder, the recording of this presentation will be made available on the No-Till Farmer website if you'd like to review what we talked about today or show it to anyone else. You'll receive an email within 48 hours with the link to the recording. That'll go to the email that you registered with. So if you have any questions after reviewing it, Brian's email is here on your screen, or you can also get in touch with me and I'll put you in touch with Brian. So on behalf of Brian, Phospholutions, and No-Till Farmer, thank you for joining us today for this digital demo. Feel free to reach out and let me know what you thought, and if you have any suggestions for other types of webinars that you would like to see No-Till Farmer do, or any topics you'd like us to cover. So thank you again, everyone, and have a great rest of your day.